Hi everyone, I hope you are all doing well. So in this video, we will be discussing what you're completing in this gas law lab. So I like this lab because I think you get to really explore the scientist in you in terms of designing some experiments. And you will also revisit some skills that you learned at the beginning of the semester. All while using and exploring more about the gas laws. So, as always, and you probably get tired of me saying this, intro is a really good place to start. It's a really good place to highlight and take notes of. Basically, it's a lot of lecture material condensed into a nice short format at times with, tables and everything's, in one place. So here we have short descriptions of the relationships and the actual laws themselves, the gas laws. And then we have the actual equations here as well. So everything is described, P is pressure, V is volume, everything's here for you to review, right? Now, as always, the main law that you will be dealing with is your PV/nRT, of course. For the most part, what we are really visiting or revisiting are these relationships. So this little sign right here, and unfortunately, I do not know the name for it, but it's just a proportion sign. It just means that whatever is on each side of each other is proportionate to each other. Now, depending on whether it's a fraction or not, or just a regular value, that is what tells you when something is indirectly proportionate or directly proportionate. So this V and T in the little proportion sign, what this tells you is that there is a direct proportionality. There's a direct relationship. If gas temperature increases, then so does volume. Okay, that's what that's telling you. Boyle's law, on the other hand, notice that I'm going to zoom in real quick. Notice that it has V on one side and then 1 over P on the other side. What that is telling you is that the relationship between these two properties is indirectly proportionate. So as gas pressure increases, gas volume will decrease. And you can see similar situations for the rest of these laws. For Avogadro's law, that's a direct relationship. For Montan's law, also a direct relationship. And then for the combined law, there is a direct relationship from volume to temperature, but there's an indirect, because that's at the bottom of the fraction, from volume to pressure. So kind of an interesting law right there. This one is actually obtained by combining Boyle's law and Charles' law. I didn't go as much into this particular law in lecture, but you don't really have to worry about it. I just presented it here to have like the complete set of laws. If you know the 4 laws that I talked about in lecture, then you're good to go. Okay, so what are we actually doing in this lab? You're opening up this PhET virtual lab, and it should look like this when it loads up. So notice again, you have different options. You're going to click Ideal. So once you click Ideal, this is the screen that you will see. So you have a lot of knobs and buttons basically going on here. So let's go back to our procedure and kind of take a look at this first before we proceed. So we're first going to work with temperature, then volume, and then pressure. Now, I feel like these steps are very pretty clear, so that you can, follow step at a time, and it will guide you through. And the simulation is not too troublesome, maybe like others that you've used in the past, but I think this one's pretty good. So, the point of me saying that is I'm going to show you where temperature can be adjusted, volume can be adjusted, and pressure can be adjusted, as well as mass. And then I will let you explore and, you know, take the reins on going through this procedure. Okay, so very important tab or information that shows here, or options that show here under this little table that says hold constant. So as of now, we have nothing being held constant, but let's say I want to hold the volume constant. Now, hopefully if you noticed, when I clicked hold volume constant, I no longer have a little handle right there. That little handle allows me to make the volume bigger, right? If I made this little box smaller, then essentially I'm shrinking the volume. But if I grab it and make it bigger, bigger volume. So that's how you adjust volume. If you click hold constant, then obviously you can't change that. Going back to nothing. So that's how you change volume. Now let's try, oh, and then here it shows you the width. So when you're actually taking volume measurements, you can determine that using those measurements. So that's volume. Now what about pressure? So the pressure reading is right there. And sorry, I meant to like point it out to you. That's that reading right there for the measurement of the length. Okay. Now for pressure, reading is right here. You can toggle between ATM and kilopascals. And to actually see a reading, we're going to have to add in some particles. So you'll see that right now. Temperature reading is right here. And you can see that you can toggle between Kelvin and Celsius, of course. To change the temperature, there's a little knob, button, whatever you want to call it right here, where you can increase the heat. See? Makes the fire. So that will you can either cool it down or increase heat. So think of, okay, I can add a Bunsen burner under this, or I can put this in a nice bucket. You can also toggle on the stopwatch. I always think that's useful. And collision counter. So how do we add in particles? So you're going to see right now that that's what this little pump is for. Now, for the part where you want to change the molecular size, you are going to toggle here between heavy and light. Heavy is a higher molecular size, molecular weight, mass. Those are all synonyms for each other. Light is a smaller. So that's where you see those differences, okay? So we're going to take this pump up, and it's going to pump some gas in, gas particles. Notice that all of these options finally, showed up. So at this point is where I can hold the volume constant, I can hold the temperature constant, I can hold pressure. You can let some of your gas out if you wanted to, and so on. So that is how you use all the different functions of this lab simulation. And feel free, there's a little tab where you can explore. There's a diffusion tab. Feel free to use all of these functions to refresh it. You can always start over and over, okay? So let's go back to our procedure. So you're going to follow all of those steps. This is all for part 1 of our data collection. I didn't split it into parts here, formally with a dividing line and everything, but that's what's going on here. So now that you are familiar with the simulation, this is the part where you are going to design your own experiments, which I think is really exciting. So for the following relationships, you will write a short description of how to use a sim to collect data. And main idea here is just describe in your own words, very brief description, how to use the sim. Like to examine this, for example, volume and pressure, to examine this relationship, I had to hold the amount, the moles. So I had to make sure that the container was sealed, that I wasn't letting any gas particles out. I had to hold the moles constant, and I had to hold the temperature constant. So, and then you would describe like on the actual sim. So I clicked this and I clicked that, blah, 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 right? So that's how your short description would look like. So you're going to do that for all of these 4 relationships. Now, each of these cases, you can consider one of them your independent and your dependent variable, right? So you're going to choose 5 independent variable data points. And those are the ones that you choose, like the value. So let's say I choose 5 pressures and I say, okay, at pressure 5 atm, 10 atm, 20 atm, and so on, right? Those are your independent data points, and then you just measure the other. So let's say I measured those pressure points, and then I measure the volume for those, or the other way around, right? But you're going to record those as Y values. And then you will use the skills that you learned back in lab 1, so a long time ago, where you graphed and you made an Excel spreadsheet, and you are going to graph these 4 scenarios. So not only are you designing your own little mini tiny experiments, but you are collecting the data, making a graph, and you will be inserting those graphs here to the lab. Now, for just exploring the sim, I give you step by step and I tell you what to do. You are going to record the values that you obtain from those steps in table 1. Remember to always include units. I always remind everybody, include units, okay? And then table 2 is where you will have your short description along with your graph. So you'll include those for all 4 relationships. Finally, for applied exercises, they're just some follow-up questions, kind of really reviewing everything. So these questions 3 and 4, you're solving some problems. So you will show all your calculations. And then for questions 1 and 2, these are more open-ended, short response type questions. So just please answer those in complete sentences. As always, let me know if you have any questions at all.